A very good morning, Dr. Gao. My name is Bharat, and I'm a member of Group 11. Today, me and my group mates are going to do a presentation on oil and gas pipeline route optimization. So before we start the presentation, I would like to walk you through the contents of the project, starting with objective of the project, methodology, network analysis, decision makers objectives, study area, routing, numerical study, construction cost of pipeline, results and discussions, and in the end conclusion. Starting with the objective of the project. Today, the unique characteristics of natural gas, dynamic economies, rapid population growth, and growing energy demand in countries have increased the importance of natural gas pipelines and the growing industrial, commercial, and construction use. Pipeline provide most convenient, effective, and economic mode of transport for oil and natural gas to different locations. One of the significant and decisive element in an oil and gas transportation complex is the building of pipelines based on the route selected. This project aims to identify all criteria and possible risks in order to achieve the most suitable and lowest environmental cost routes.
Next, coming to the methodology, it has three types of methods like we use in this. Optimization in oil and gas pipelines uses invariably economic criteria, namely maximization of the net present value. Financially specialized natural and security complementations out to be essential components, overseeing the choice of pipeline courses. And we have three. One is integer programming, linear programming, and network analysis programming. Uh, And basically, the methodologies are depending based upon the economic criteria, technical and environmental impact, and the safety constructions. These are the primary factors used for choosing the pipeline and the routes. Among this, all three methods, the most popular method and the method we use here is network analysis programming. And then coming for the interior programming, it's a kind of programming we use the straight optimization issues that require a few of the factors of the integrability are called blended number programs. Excuse me. Then coming to linear programming, programming is an optimization strategy for a framework of straight limitations and direct objective work. And objective work characterizes the amount of optimized and objective of direct programming is to discover the values of factors that maximize the objective work. In this project execution, the main focus is on network analysis.
Coming to the network analysis, here the network analysis is done using the MS Excel in this project, and we can choose the minimize cost and the minimize crossings, and the optimization is supposed to play a major role in lowering the gas pipeline network design and operating costs. And the advantages of the network analysis is minimize the production delay, interruptions and conflicts, and minimization of the total project cost and trade-off between the time and cost of project, minimization of total project duration, and minimization of ideal resources. And we can set the cost as the objective and consider the crossings as a constraint to obtain a multiple object and select an optimum route for the network analysis.
Nihant, you there?
Study area. Study area is nothing but the field of study for a specific geographic area. For this, Texas was a potential study location initially, but later we ended up choosing California. For this study area is Palo Verde Unified School District in southeast region of California. As a starting point in which the coordinates are 33 degrees 39 minutes north, and 114 degrees 43 minutes west. Similarly, the endpoint of the study area is Elk Hills Elementary School, which is also in California, in which the coordinates are 35 degrees 16 minutes north and 119 degrees 18 minutes west. Uh, this study area is located and created by using the Google Earth Pro desktop software. After this locating and creating, we have done creating the paths.
Hello everyone. So in creating a route, we have to like the main objective in creating a route is to determine a route that will result in the most effective design that has smallest carbon footprint and also the most cost effective way construction. So for this we have to carefully examine the terrain, the slopes and everything, reduce the maximum slope, avoid any high terrains like mountains, valleys, and avoid crossings like tunnels, highways, and also to reduce the final construction cost. And we have to uh, you know uh, take responsibility for any environmental impacts. So for the environmental uh, impact, it plays a major role in influencing on operational safety and constructability of the pipeline. So also this look, knowing the population density has an major role in acquiring the wall thickness of a pipeline through the length of the area that is close to the population. So if the pipeline is very near to the population density, then the pipeline wall thickness would be different than the pipeline which is far away from the any populated area. So this like surveying and everything would be done through an arduous process of counting buildings along a sliding mile length of a pipeline. Generally we have to we'll see the like that we will know the area through any Google Maps or anything, and segregate the areas to most urban, middle urban, and least urban, and also most rural, middle rural, and least rural. So when coming to the terrain of the route has large impact on the productivity of the construction. So like if the terrain is more like if the terrain is high or the steep is like high, then it makes the crew and equipment to run slow when considered when we have terrain normally. So like means like if the construction is on an inclining plane or any declining slope, then the construction takes longer than expected, and the more and the CO2 emissions will be more from the equipment we're going to use in the construction. So not normally the slope we consider is the maximum slope is we'll consider is 0 to 15%. That's an ordinal slope, but we shouldn't consider the routing in a construction where the slope is over 45%.
So coming to the crossing, with each route there will be roads, railroads, and walkways to cross. So each of the crossing that are encountered will be required additional crew to cross the road or walkway. And additional construction time depending on the size of the road or walkway. And the team will have to make sure that each of the crossings are accounted and included in the total construction crew makeup. So team will have to determine with the selection of the route either to minimize the crossing with the longer route or to carry out the crossing with the shorter route. So for the project, we have considered different types of crossings. So they are two-lane paved road, which we use when additional burial depth and more construction design factor is required. And the other one is if it is greater than two-lane paved road, it is used when boat crossing or move around is required. And if it is between 0 to 50 feet water body, we are gonna use this in additional depth and protection of water quality is required. And if it is greater than 50 feet water body or canal, we are gonna use this in horizontal crossing or move around is required. And the last one is railroad. We are gonna use this in boat crossing or when a move around is required. So next slide is gonna take care with my friend.
Hello everyone. Coming to pipeline routes. As you can observe the picture, we have taken the pipeline route is created using Google Earth Pro software. We have multiple range of routes. So we have selected the following coordinates which are from Southern California are the starting and ending coordinates as mentioned in the table given below. The paths were created by using the path option in the software by carefully examining the terrain to reduce the maximum slope by avoiding high terrains like mountains, valleys, and also avoiding the crossings of tunnels and highways, which can reduce the final construction cost. We have reduced as much as distance as we can to reduce the cost of construction, and the final route is created after eliminating the high slopes and populated regions in the study. So the complete route of pipeline route starts from node A P1 2 and ends at node B P5 2.
Numerical study. Uh, we have uh, we have to calculate the number of crossings at each point, that node to node. Measure the EI distance at each path. EI distance is nothing but environmental impact. Measure the distance of each path. Calculate the construction cost for the each path. Uh, as we calculated, the maximum EI distance is 94.3. That is between node P3 to P4 3, and the minimum EI distance is 0. That is between the node P1 1 to P2 1, and the maximum number of crossings between P4 1 to P5 1, and it is 11. The minimum number of crossing is 0. That is between starting point to P1 2 and the starting point to P1 3. Uh, and these values are tabulated in Excel sheet. As you can see here, the some of the sample values I have presented on this slide. Uh, the total cost is dependent upon the two things. It is diameter and the length was given from these numerical studies. I think my friend gonna take over.
So coming to the construction cost of the pipeline, we have taken one formula which you can see in the slide. It is nothing but 674 dia square plus 11,754 diameter plus 2 lakh 34,085 into length plus 4 lakh 5,000, where diameter is in the inches and length is in the miles and cost is in the dollars. So the material which is transported, I mean, the material transported is the natural gas, and the diameter of the pipes is assumed as a 24-inch. And the total construction cost is calculated between two nodes, and the cost is tabulated in the form of Excels. And next slide.
As Vinay explained the numerical study, the network analysis is done in Excel sheet using solver, after which the results are obtained using two different perspectives. The first perspective is single objective, in which we obtain single optimum result, in this case, one optimum route. We have used solver to get optimum routes for minimum total construction cost and for minimum crossings and for maximum EI distance. The second perspective is multi-objective. In this case, we have considered only two objectives as multiple objective, from which we get a range of desired results. In this case, a range of routes. We considered one as an objective and other as a constraint and multiple objective. And we use solver to get optimum route ranges for minimum cost and minimum crossings, and for minimum cost and maximum EI distances. The demographic on the left is for an optimum route obtained for minimum cost without any other constraints, that is $313 million. And on the right, we have a demographic of the optimum route of minimum crossings, that is 23 crossings in our case. This is a demographic of the optimum route for maximum EI distance, that is 246 miles. Initially, the objective, the multi-objective was to consider minimum cost and minimum crossings, but the results were unsatisfactory as there was only one optimum route in this case. Then the objective is changed to minimizing the cost and maximizing the environmental impact distance. The minimizing of cost is considered as the objective, and the EI distance is considered as the constraint. The trade-off graph on the right shows the points from minimum cost in blue at the bottom and maximum EI distance in green at the top. Generally, in multiple objective problem, all the points on the trade-off curve are the required or desired outcomes of the problem. Neglecting the first and last points of the curve, the other 5 points in this graph are our optimum results. These are the following routes in the next slides. These are the options out of which one can be selected. We can present these 4 routes as our solution for the multiple objective of minimizing cost and maximizing EI distance, out of which one is chosen by the relevant party.
So finally, in conclusion, we can conclude that this cost estimate methodology for onshore pipeline transportation of natural gas was very useful. And then usage of network analysis in this particular project was found to be an advisable option. And the optimum results obtained from many possibilities are shown in the above slide that has been shown in one of my teammate. And multiple objective optimization was found to be a feasible option. And then the optimized gas supply networks from gas distribution stations on rough terrain. And then so by optimum results for further studies, we can consider other aspects which generally affects the pipeline routes, such as hydraulics of the pipeline and carbon dioxide, that is CO2 emissions, etc. So by doing this project, we have identified all the criteria and all possible risks in order to achieve the most suitable and the lowest environmental cost route. Thank you.